In our laboratory, for the purpose of understanding basic features of flow phenomena, we are investigating various flows around sweet objects. For example, vortices shed from wingtips, sound generation near sweet boundaries, and flows around flying or swimming creatures. In order to realize computational simulations of these flows, we pay special attention to the volume penalization method. The method allows us to do numerical simulations of flows around moving or deforming sweet objects with a complicated geometry. Usually, when we perform numerical simulations of flows around sweet objects, we generate a computational grid system along the surfaces of the objects and calculate physical quantities on the grid points. Then, boundary conditions are imposed for the physical quantities only on the surfaces of the objects. But it is difficult to form the grid system along the bodies with intricately shaped geometry. And if the bodies move or deform, the computational procedure becomes more complicated one. On the other hand, using the volume penalization method, we can make use of the Cartesian grid. The surface boundaries are immersed in the grid cells. And the implementing of the volume penalization method for existing computational program is very simple. We need to just add one term to the Navier-Stokes equation for incompressible flows. Moreover, the volume penalization method can be used with the high accuracy space discretization scheme, like the spectral method. This means that the method have a possibility for the high accuracy computations of flows around moving or deforming sweet objects with complicated geometries. This is the movie of the vortex pair formation. When the piston stops, the boundary layers are ejected from the edges of the plates and roll up into spirals, and the secondary vortices of opposite sign grow too. We are investigating the process of the vortex formation in detail by using the volume penalization method. Furthermore, we are trying to apply the method to compressive flows and three-dimensional flows around a variety of objects.